What turns games from just working to crazy addictive? Yeah, it's game fear. And today I'm going to show you how to achieve that good juice with FeelCraft, a simple and fast tool that allows me to add all these effects in just a few minutes. After importing the tool in my project, I create a new empty object in my scene and attach the Feel Manager component to it. I then create a new Feel folder in my project to organize my animation. Personally, I find it easiest to organize them by prefab, then by states, and finally by child objects. I will start by adding a squash effect to the ball when it hits an obstacle. It will be simple and subtle, but it's a great introduction. I create a ball folder, then a hit folder. Inside, I create an animation group. Right-click, create, FeelCraft, base, group. Animation group compose complex behavior from several simpler animation layers. I create my first layer. Right-click, create, FeelCraft, specialized, transform, scale. Layers are additive and can stack on top of each other. Here, I'm going to modify the offset value to apply a deformation on the Z-axis. I choose a duration and an animation curve. The curve allows me to control how the offset is applied over time. When the curve is at 0, no offset is applied. At 1, the full offset is applied. And at -1, it's inverted. Then I reference my layer in the group. Now, I open my prefab to add the fill component. No matter what, I always need one at the root of the object with the isParentFill option checked. This parentFill component controls the available animation and handles triggering them for all its children. I define the hit state. In my case, the root has no visual mesh and is only used for game logic. The visual part is in the skin child, so I can leave the group undefined for the root. I add the fill component to the child, define the hit state, and reference my group. All that's left is to trigger the state from the code. I open my ball class and call FeelManager.trigger from my collision detection logic. It takes a state name. Several are built-in, but you can add as many as you want. A multiplier factor, a maximum number of animation cycles, the list of affected entities, and finally, whether the state should propagate to the affected children. It's subtle. Let me zoom in so you can see it better. Next, I'm going to add a light flash when a brick gets hit. I start by adding a light to my prefab. I choose a color and set its intensity, indirect multiplier and range to 0. Same principle, I create my folder hierarchy and an animation group. My first layer enable/disable an object. It works like a boolean. When the total offset is above 0.5, the object is activated. Otherwise, it's deactivated. I will create a specific curve that starts at 0 and immediately jump to 1 to activate the object instantly. I save it for later use and choose a duration. My second layer will control the light intensity. Same process, I choose my animation curve, duration and offset. I do the same thing again, but this time for the range, I reference my 3 layers in my group and the fill component to the root of the prefab with isParentFill checked and add an empty hit state. Then I add a fill component to the flash child with the same state and link my group. This child will start deactivated. Trigger animation from the code and look at the result. It's not bad, but I want the impact to feel stronger. I'm going to make the cube retract, light up, and jump to emphasize the hit. I create my folders, a new animation group, a layer to control the material emission, one for position and another one for scale. I link them to the group, add a fill component to the skin child, and a hit state linked to my group. I will increase the elimination a bit more. That's better, but it still lacks physical consistency. I want the brick to be pushed in the direction of the impact. There are two possible directions, the y-axis or the z-axis. I start with the x-axis, create new folders, an animation group, and a layer for the X position. I repeat the steps for the Z-axis. I add a hit right and a hit forward state to both the root and the skin child. Then, in code, I trigger the state based on the impact normal. To reverse the animation direction, I just need to pass a multiplier of -1. Now, I'm going to add more impact when a brick is destroyed. I add a new light to my prefab with its fill component and a killed state. Then I create a new animation group with a layer for activation and one for intensity. I link the group to the state and remember to add this new state to the root. Thanks to this tool, I can also request the object to be destroyed at the end of the animation. I will create a new group for the root object, give it any dummy animation layer, and check the ending destroy option. Using the same logic, I add a scale effect to the skin. I go back to my code and replace the old line with my animation trigger. I would like to emphasize the brick destruction even more by adding a light effect when the player scores a point. I create my folders, a new group, and two layers linked to the material color. I just need to define the property name to modify, in this case, the emission color channel and another for base color. I add this code state to my fill component and link the animation group. In the code, I will listen to the onDes event of my bricks to trigger the scoring animation. My goal is to have the lighting effect start from the top of the level and move towards the bottom. I iterate through each row of my grid, increasing the delay for the animation slightly for each row, and then each column. If a brick exists, I trigger the animation. Material modification can be quite expensive, so I won't overdo it. I will only apply them to the outer brick of the level. Finally, I pass the desired delay as parameter. I will do the same thing in reverse, but with a red color, when the ball hits the net. Now, I will add more impact to the paddle. I create my folders, my group, an emission layer to light up the paddle, a position layer to make it kick back on impact, and a scale layer to make it more dynamic. I add the fill component on both the root and the child, create my states, and update my code. I repeat this step to activate the light child on impact. To boost the game feel, I'm going to add a camera shake. A powerful one when the ball is destroyed, a very subtle one when a brick gets hit, and a slightly stronger when a brick is scored. Finally, we need a light effect at the impact point between the net and the ball. I add a light controlled by the tool, trigger the animation from the code, and since I need the light to move exactly to the impact point, I add a small logic snippet directly in my code to reposition the light. With this tool, your game will become truly satisfying. The download links are in the description. Regular updates are planned to add more features, and price will increase a bit for each update. As a thanks to your early support, if you get the tool now, you will benefit from a lower price and have access to our future update for free. I hope you enjoy the video. If you have any question, feel free to ask them in the comments.